Hi everyone, I am the founder of the Grey Blind Doll. Today we continue our lesson from the point where we left off in functions. In this tutorial I will show you how to transfer arrays between functions. I will also explain how we can process this data on functions after the transfer takes place. As the dimension of the data increases, the complexity will also increase. Therefore, as the complexity increases, the number of methods we can use will also increase. We will start our lesson first with one-dimensional arrays, then we will continue with matrices. In the first half of our lesson, we will define an array and write two functions that sums its elements. These two functions will be functionally exactly the same, but will differ in the way they receive and process the array. We include our library hashtag include stdio.h. I define prototypes of these two functions. We will return to this topic later in the lesson. Integer sum array version A and integer sum array version B. Okay, we create our main function. Integer main, the brackets and the curly brackets. Now we define our variables and our array. We create an integer array 20, and we create three integer variables, limit for the array's limit, and I to be a counter, and sum to keep the sum of the array's elements. Okay, integer array with 20, limit value, and I is equal to 0, sum is equal to 0, and semicolon. Now, we ask the user to enter a limit value and we get it. After that, we ask the user to enter the numbers and we get them. Okay, execute, compile, and run. We are here now. Please enter the number you want to enter. We are here. Please enter the number you want to enter. Scanf the person sign D, ampersand, limit, and semicolon. Now, I will enter here 3. And please enter the numbers. We are here. Please enter the numbers. And for I is equal to 0, I is less than limit, and I plus plus. Printf the person sign D number, I plus 1 for this person sign D, and scanf the person sign D, ampersand array I, array, and our index. Okay? Now I will enter the first number here, 1, the second number here, 2, and the third number here, 3. As you can see, our result is equal to 6, and our result is equal to 6. The answers are the same. And this answer belongs to our first function, and this answer belongs to our second function. Okay. Let's take a look. We have created our array, and now it is time to pass them to our functions. We have created our array, and now it is time to pass them to our functions. When sending an array to another function, here important, only the name of the array is written. Only the name of the array is written. Even if we use a reference in the prototype, we use a reference in the prototype like that. Integer pointer. Normally we have to send an address, but we send an array, and our array is an address collection. Okay, is an address collection, so we do not have to use an address of sign. Okay, we do not have to use ampersand array. We use only the name of the array. Okay, so our function here, sum, is equal to, because our function returns a value, an integer value, so sum is equal to sum array version A, our first function, array and limit. Array goes here, integer pointer, and limit goes integer. I do not want to change limit. Okay, I do not want to change limit, so I do not use a reference sign. Good. Now, we are here now. This is the first version of our function. This is the most common and memorable method. This is the most common and memorable method. We use a star with the name of the array at the definition part in this method here, integer pointer array. With this usage, you will be able to use the classical appearance of the arrays, array and square brackets. Okay, array with square brackets, like that. But if we use the second method, like that, integer array square brackets in the definition part of our function, we cannot use this usage. We cannot use this usage. And we have to use this usage. Okay? We have to use this dereferenced method. Okay? So, in our first function, we create two variables, I to be a counter and sum to keep the sum of the array's elements. These variables are not known by the main function. This is the important part. These variables are not known by the function. These I completely different from this I, and this sum completely different from this sum. Okay? Therefore, the names look like the same with main functions variables, but their addresses completely different from them. Their addresses completely different from them, although their names look like the same with main functions variables. Okay, now we add the elements with the classical format of arrays. So for I is equal to 0, I is less than limit, and I plus plus, sum is equal to sum plus array I. This function knows our array because we sent it before here to this function. Okay, return sum. We return the sum value to our main function, here sum, from this function, and we put this sum into this sum. Okay, and we print our sum on the screen, printf result the person sign d sum and semicolon. As you can see, result is equal to 6. Okay. Before sending our array to the other function, I reset the sum so we can see the effect of our second function. So I reset our sum is equal to 0 and semicolon. Now our sum is equal to 0. Now we send our array along with the limit value to our second function. Okay, sum is equal to sum array version b array limit. As you can see, the same method so far. Now we used this method and we sent the name of array and the limit value of the array. And now this is our second method, and we use again the name of the array and the limit value of our array. We are here now. This is the second version of our function. This version is used very little compared to the first version. We use the classical appearance of arrays at the definition part in this method, like that. And with this usage, you will not be able to use the classical appearance of the arrays with square brackets. You have to use the alternative appearance when you apply to use this method. A reference, array plus index and semicolon. We use this usage when we use this appearance in our definition part. Okay. Now we create two variables again, I to be a counter and sum to keep the sum of the array's elements. These variables are not known by the main function again. Therefore, the names look like the same with main functions variables, but their address is completely different from them. The same rule. Integer I is equal to 0 and sum is equal to 0 and semicolon. We add the elements with the second format of arrays. Star, array plus index or counter. For I is equal to 0, I is less than limit value, and I plus plus. Sum is equal to sum plus the referenced array plus I. Okay? Star sign, the parentheses, array plus I, and semicolon. We return the sum to the main function, return sum, and we put this sum value into this sum value, and we print our sum on the screen. Here, result is equal to 6, and our results. The prototypes of both functions and the way they receive data in the main function are the same. As you can see, the prototypes are the same. Integer pointer for our array and integer for our limit value. As you can see again, integer pointer for our array and integer for our limit value. They are different functions, but their prototypes are the same. And sum is equal to sum array version A. We send array with its name and the limit value, and the version B array and limit value. As you can see, the methods are the same. Okay, this is our first result. And now the second result, we can say that the main differences between the two methods are the way they are defined in functions and how they are used. They are defined in functions and how they are used. Okay, if we define like that, integer pointer array, reference array, we have to use our classical usage, array I. This is legal. But if we want to use the classical usage in the definition part of our function, like that, array the square brackets, we have to use the alternative usage in this function, like that, reference, the brackets and array plus our index. Okay? And its rule, it can be kept in mind that if reference is given in the definition, no reference is used below, and or if no reference is given in the definition, it is referenced below. It can be kept in mind like that. Okay, the answer to the question of how we will know which of the methods we should use is that it is completely optional for you at this stage. Okay, this is completely optional for you at this stage. It's not important. You can use this method if you like this method, or you can use this method if you like this. If you want me to say one of them, I can say that the first method is more common and more suitable for most of you in terms of usage. Okay, so I use this method, but sometimes I use this method. Okay, sometimes I use this method, but generally I used this. Okay, we finish our program here. Return 0. That is it for this week. Next week, we will learn to pass matrices to functions and manipulate them just as we send and process arrays. Actually, I wanted to cover this process as the second half of this lesson, but I thought it would be more appropriate to divide the video into two parts. Thanks for all your effort and patience. See you following lecture. Stay tuned.